Okay, now that we've established some trig functions, we're going to talk a little bit more about angles and make sure we've got everything all explained with those. So the first thing we need to know is we need to know what a reference angle is, because we're going to use this when we're finding the trig ratios. So a reference angle is the angle formed by the terminal ray of a given angle and the x-axis. So if you have an angle and it's right here, then its reference angle is the same as the angle. But if we have an angle, let's say it's over here, then we would normally name that angle in its standard position with this measurement here. But a reference angle would drop you straight down to the x-axis. So this would be the reference angle for that angle. Or if we were in this quadrant here, we would normally again measure off the positive x-axis, but the reference angle would be straight to the nearest x-axis. And again in the fourth quadrant, we would normally measure it all the way around from the positive x-axis, that's standard position, but our reference angle would be to the nearest x-axis. Now why is that important? Well, we use it to figure out all our trig functions, because for the trig functions we're using right triangles, which means that we have acute angles that we're looking at. And acute angles, remember, that's less than 90 degrees, so we need these little reference angles because those are the ones that are going to be less than 90 degrees so that we can figure those out. Now, when we have these reference angles, we can look at how that relates to our trig functions. So our trig functions here are between 0 degrees, the angles are between 0 degrees and 90 degrees, or from 0 to pi over 2. Remember, we talked about how to change from radians to degrees, and so this is pi over 2 radians. So in this first quadrant here, we're looking at these angles that are between 0 and pi over 2. And in the second quadrant, the standard position of the angle would be from pi over 2 to pi, or from 90 degrees to 180. And then in the third quadrant, the standard position would be from pi to 3 pi over 2 radians, or 180 degrees to 270 degrees. And then in the fourth quadrant, we would have from 3 pi over 2 to 2 pi, or from 270 degrees to 360 degrees. Now these are the standard position angle measures, but as you can see in the second, third, and fourth quadrant, we can't really do those with right triangle trigonometry. So the first thing we need to do is decide what quadrant we're in, and then we'll be able to use our reference angles to find the sine, cosine, and tangent. Now, one thing you need to remember about the trig functions is we've got sine and cosine, and these are our two main ones because you learned last year that the tangent is sine divided by the cosine, and then all the other reciprocal ones, the cosecant is 1 over sine, and the secant is 1 over cosine, and the cotangent, remember, is 1 over tangent, which means we take the reciprocal of this right here, it's cosine over sine. So if we can get everything boiled down to sine and cosine, then we can find any of the others. Now, we're going to talk about something in class called the unit circle, which is going to give us, it's kind of like multiplication tables. You memorize certain sines and cosines of angles, certain key angles, so that you can use them for other ones. But one thing that I want to just kind of point out here is when we have an angle that's in this first quadrant, both our x value, that adjacent, and our y value, that opposite, if we draw in the triangle, if we're looking at this angle here, the adjacent side to it and the opposite side to it are both positive. So that means that sine is positive and cosine is positive. Now, in the second quadrant, if we have an angle, our reference angle is going to be here that we're going to use for sine and cosine. And you notice that this adjacent is a negative x value. So that means the cosine of theta is going to be negative, but again, the sine is positive. Now, in this third quadrant, the adjacent, like we said, is negative. And now we're going down below the axis, so that means our sine is also negative. And then in the fourth quadrant, again, the adjacent is positive, but we're going down below the x-axis, so the opposite is negative, so that makes our sine negative. So you need to kind of keep that in mind when we're thinking about which quadrant we're in and what happens with sine and cosine. So let's look at how this all works. Let's say we have an angle, and it's over here, and it's the angle 7 pi over 6. Now, for 7 pi over 6, that's our standard position angle, but for it to be able to find my trig functions easily, I need this reference angle. So what I do is I go to the nearest x-axis, and I look at this and I say to myself, well, am I using part of a straight line, or do I have some straight line piece that I need to get rid of? So we look here and we see that we have this straight line piece here that's kind of extra. It doesn't go with the reference angle. Now a straight line is pi radians, or 180 degrees. So in order to find this reference angle, because we have to get rid of that part, we're going to take the angle measure and subtract off that straight line part that we need to get rid of. Make sure you can picture this and see, because sometimes we're going to be adding the straight line, sometimes we're going to be subtracting it. You need to know why we're doing this. So we have this whole angle here. We just want the reference angle, which goes to the nearest x-axis. So there's a straight line piece that we need to get rid of. So we're going to subtract pi. So when you subtract that, you get pi over 6. And that is our reference angle. We'll call that alpha. So we have this reference angle, and we can now use our unit circle, which we'll talk about in class a little bit more, to find the sine and cosine. Now you can also, of course, use the calculator to find these out, or you can, if you recall, you studied in geometry something called a 30, 60, 90 triangle. In radians, that's pi over 6, pi over 3, and pi over 2. So this is part of a 30, 60, 90 triangle. This is the 30-degree part. And you'll recall that across from the 30 degrees, it's 1 unit, and then you double it for the hypotenuse, and you multiply it times the square root of 3 for the longer leg, which means if we want to find the sine of pi over 6, which is the same thing as the sine of 30 degrees, then we would have 1/2. Now, the thing we have to remember with this is we're looking down in this third quadrant. So we look in this third quadrant, and we've got this triangle we can draw in here. We said this is the 30-degree, or the pi over 6 angle, so that means this one is 1. But it's below the x-axis, so it's -1. And then here we've got the longer leg, which is square root of 3, and the hypotenuse, which is 2. So our sine is going to be -1 over 2. And the cosine is this adjacent over hypotenuse, and just leave it like that. There's no need to put it in the calculator. Now from all of these, of course, we can find the tangent. Tangent of pi over 6, we can either do sine over cosine, or we can do opposite over adjacent. And again, they'll rationalize this, but you don't really need to. The cosecant of pi over 6 is the reciprocal of the sine, so it's just -2. The secant of pi over 6 is the reciprocal of the cosine. And the cotangent of pi over 6 is the reciprocal of the tangent. So then you can get all of these angles. So make sure you understand about the reference angles and how to find the reference angle, because we're going to use that when we talk about the unit circle in class. And the other thing that you need to make sure you understand is you can just punch it in your calculator, but you have to check your mode. Okay, so if you're going to use your calculator, you need to go to mode and decide either you're going to be in radians or you're going to be in degrees, and select whichever one it is. And then in your calculator, you just type sine of parentheses pi divided by 6 close parentheses equals, if you're in radian mode, and it'll give you -0.5. So your calculator can give it as well. So make sure you know how to do that. And one last little thing that this book does that's kind of uncommon now, but make sure you remember about minutes and seconds. We talked briefly about that, but for example, if you've got 78.33352 degrees, you take this part here and multiply it times 60, and that gives you the degrees in minutes. So we'll have 78 degrees, just leave that there. Then multiply that times 60, and you get 20 approximately, and that'd be 20 minutes. Now if you had the minutes, you would divide by 60 to get back over here to the decimals. So just as a little reminder, make sure you've read section 1.3, taken some notes, written down your questions. We'll go over the unit circle and some more of that in class.